Hi everyone, Mrs. Bradshaw here. Today we are going to continue our study on volume. Our learning goals today is to decompose composite figures to find volume. The word decompose means to break apart, to split up into smaller pieces. So you're going to see shapes that look like this. This is a little bit different than what we've been seeing when we work with volume. So when we see a shape like this, the first thing that we need to figure out is where can I decompose or split this figure up to help me solve the volume? So in this figure, I see a couple of spots right away that I think that I could decompose. The first one I see is right here. I can decompose the figure by breaking it apart right there. So let's go ahead and try that. So here it is. I can pull the figure apart, and now I have two different pieces of the figure. And I know that I can find the volume of these figures using our two different formulas. So I have volume equals length times width times height. And I also know the other formula is volume equals base times height. So let's find the volume of each figure. So this first one, I have 1, 2. So I have 2 times 1, 2, 3. And I have 3 layers, meaning the height is 3. So 2 times 3 is 6. 6 times 3 is 18. So I know that the volume of my first figure is 18 cubic units. But I need to find out the volume of my second cube as well, my second part of the figure. So I have 1, 2, 2 times 1, 2, 3 times, this is where they differ, this one only has a height of 2. So I know 2 times 3 is 6. 6 times 2 is 12. I now have two different numbers for volume. I have to take the volume of both the first figure, figure A, and the volume of figure B, and add it together to find out the total volume. So 18 plus 12 equals 30. So my total volume for this figure is 30. And I found that out because I decomposed by pulling it apart into two different figures to find the volume using our formulas. Now, there's another way I could have done it as well. I could have decomposed the figure by splitting it here and taking off that top part. So let's go ahead and look at that. So here it is. I pull off that top part, and now I am left with two figures. I'm going to label this one figure A, and I'm going to call this one figure B. So let's find the volume of figure A. I'm using my formulas that I know, length times width times height. So 2 times 3 times, and you'll notice I only have one layer, so I'm going to multiply the height by 1. 2 times 3 is 6. 6 times 1 is 6. So the volume of figure A is 6 cubic units. Let's find the volume of figure B. My length, 1, 2, 3, 4, is 4. My width, 1, 2, 3, is 3. And my height, I have 2 layers, times 2. 4 times 3 is 12. 12 times 2 is 24. So the volume of figure B is 24 cubic units. I now have two different answers for the same problem. So what I have to do is I have to add the volume of figure A and figure B to find the total volume for the composite figure. So 24 plus 6 equals 30 cubic units. You will notice that we got 30 cubic units even though we decomposed this figure in two different ways. That is the nice thing about volume. We can both approach it in different ways and still end up with the same volume if we do it correctly. So let's try another one. Here is another figure. I want you to take a moment and figure out how you could decompose this figure to find the volume. All right, let's go ahead and try to solve it together. So the way that I see this to begin with is that I could decompose the figure right here. So let's go ahead and try that. Let me go down. So if I'm going to decompose the figure right there, I'm going to take that part and move it away. I now have two separate figures. I'm going to name this one figure A and this one figure B. I can tell just by counting that figure B is 1, 2, 3. The volume of figure B is 3 cubic units. Let's find the volume of figure A. So I have 1, 2, 2 times 3, so length times width, times my height of 2. I know 2 times 3 is 6, times 2 is 12. The volume of figure A is 12 cubic units. I now will have to take figure A and add it with figure B. So 12 plus 3 is 15. The total volume for our figure is 15 cubic units. Cubic units. And remember, cubic units is the qualifier, the label that we use to signify that we are using volume. So going back, here was my figure to begin with. Some of you may have chose to split the figure up in a different way. Instead of splitting it the way I did, you may have decided to take that top layer off and split it like this. Let's go ahead and try that way. So taking the top layer off, I'm just going to move it over to the side. I now have two different figures. I have figure A and I have figure B. Let's find the volume of figure A. Since it is only one layer, I can see all of the different cubes and I can just count. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. The volume of figure A is 9 cubic units. Let's try figure B. 1, 2, 3, 4, 5, 6. The volume of figure B is 6 cubic units. I have now two different answers for the same problem. In order to find the total volume for our original figure, we have to add figure A and figure B. So 9 plus 6 is 15 cubic units, or units cubed. So going back to the original figure, when it was put together and not decomposed, we split it up in two different ways. Both ways that we split it up gave us our answer of 15 cubic units. Let's try this one. I would like you to go ahead and pause your video now and try to see how you can decompose this figure to find the total volume. All right, looking at this figure, I think that I would decompose by pulling this part off here. So let's go ahead and try that. Pulling that bottom part off and moving it away, I now have two separate figures. I have figure A and I have figure B. I can see what figure B's volume is just by counting the number of cubes. I see that figure B's volume is 4. Let's find the volume of figure A using our formula, volume equals length times width times height. I see that I'm going to have 2 times 1, 2, 3 times a height, or the number of layers, 1, 2, 3, 4. I'm going to change my pen so we can see that a little better. 2 times 3 is 6. 6 times 4, I know, is 24. So I now have 2 different answers for one problem. I know that since I decomposed the figure, I have to reconstruct it by adding figure A and figure B together. 24 plus 4 equals 28. The volume for our figure is 28 cubic units. 28 cubic units. You may have decided to deconstruct or decompose this figure in a different way. If you still got 28 cubic units, great job. So that is one way that you were able to see them, and you got to see me actually deconstruct them. When you are working on your problems, you're actually going to see them look more like this. So when we see this, we're going to take what we learned from the previous slides and apply it to a problem like this. So looking at this, I personally think that the easiest way to deconstruct would be cutting the figure right here. Now, I really can't just take this figure and pull it apart, so I have to do it in my mind mentally. I'm going to label this part over here figure A, and I'm going to label this part over here figure B. Looking at figure B, I can tell just by counting. I have 1, 2, 3, 4, 5, 6, 7, 8. The volume of figure B is 8 cubic units. Let's try to find the volume of figure A together. So A, I'm going to do length times width times height. So I have 2 times, so because figure B is in the way for me to count that bottom layer, I can go up to the top because I know that I can't have floating cubes, so I can count that, or I could come all the way over here and count here. In this case, I'm going to stick with figure A and just go up to the next layer. 1, 2, 3, 4. So a length or width of 4 times a height, the total number of layers, 1, 2, 3. 2 times 4 is 8. 8 times 3 is 24. So the volume of figure A is 24. So because I decomposed this figure to find the volume of figure A and figure B separately, I have to add them together to find the total volume of this entire figure. So 4 plus 8 is 12. Put my 2, carry my 1. 2 plus 1 is 3. So the volume of this total figure is 32 units cubed, or cubic units. Let's go ahead and try this one. I would like you to pause your video and try this one on your own. Let's go ahead and try to solve this one together. Remember, you can split it in a different way than I split it. I am going to decompose the figure right here. So if I had a knife, I would be cutting it right there to try to decompose like we did with the first few. So I'm going to label this one figure A and this one figure B. So for figure A, I know I'm going to use the formula volume equals length times width times height. My length here, I have 1, 2. So volume equals 2 times, let's find the width, 1, 2, 3, but I can't stop there because my figure goes on, but just figure B is in the way. So I'm going to go up to the top here and see if I can count that way. So 1, 2, 3, 4, 5 times 5 times how many layers or what the height is? 1, 2. So volume equals 2 times 5, I know is 10. Volume equals 10 times 2 is 20. So 20 cubic units. So that is for figure A. I now have to figure out what the volume is for figure B. Using my same formula, volume equals length times width times height, I'm now going to plug in numbers for those variables. Remember, a variable is just an unknown number. So volume equals 1, 2 for length times my width, 1, 2, times my height, 1, 2, 2 layers. So volume equals 2 times 2 is 4, and I'm just rewriting that problem. Volume equals 4 times 2, which is 8 cubic units. Am I done? I am not done because I found the volume of each figure as they were decomposed. I now have to add 20 plus 8. I know if I add 20 plus 8, I get the volume of 28 cubic units, or 28 units cubed. This is the answer for my entire figure, putting it back together. We have one more problem that we are going to solve together. I would like you to pause your video now and try this figure on your own. All right, let's go ahead and solve it together. Remember, you can decompose your figure in a different way than I decompose mine. So the first place that I saw to decompose was right here. So I'd be taking that top layer off. So I'm going to label this bottom part figure A and the top part figure B. I noticed that figure B is just one single layer, and I'm able to see all of the cubes. So the volume of figure B, 1, 2, 3, 4, 5, 6, 7, 8, is 8 cubic units. Let's find the volume of figure A. So I'm going to use volume equals length times width times height. So I'm going to find the length, 1, 2, 3, 4. So 4 times a width, 1, 2, 3, 4, and a height. I'm going to change my pen just so we can see. 1, 2, I don't want to go up too high because then I'm going to get with figure B. So remember, I cut it right here, so we have to pretend that that is not there. So just looking at figure A, I see that I have 1 layer, 2 layers. So my height of figure A is 2. 4 times 4 is 16. 16 times 2 is 32. I have now found the volume of figure A and figure B when we decomposed the figure. But that is not my answer for this problem. I have to add or reconstruct by adding 32, the volume of figure A, plus 8, the volume of figure B. 32 plus 8 is 40 cubic units. I hope this video was helpful in teaching you how to decompose a figure.